Hi, grade 8. Welcome back to the science class. How are you all? Today, let us learn a new topic, patterns of reactivity. I have already taught you this in the regular class time, but this is not in your syllabus, but I am taking this for your Cambridge exam. Okay. What is meant by the reactivity series? In a reactivity series, the most reactive element is placed at the top and the least reactive element at the bottom. More reactive metals have a greater tendency to lose electrons and form positive ions. What is reactivity? The rate at which a chemical substance tends to undergo a chemical reaction. The metals have different levels of reactivity. The reactivity series is a list of metals with the most reactive at the top. For example, sodium is more reactive than iron. Sodium, when exposed to air, its shiny surface quickly tarnishes. Iron, when exposed to air, it slowly oxidizes and gets rusted. This we studied in chemistry in everyday life. That lesson we studied this one. Metals have different levels of reactivity. When a metal reacts with oxygen, a metal oxide is formed. Here some examples are there. When copper is heated with oxygen, a black powder will form. When heated with oxygen, iron produces yellow sparks and a black powder is left behind. When gold is heated with oxygen, no change occurs. When sodium is heated with oxygen, it will heat to burst into yellow flames, burns quickly to leave a white powder. We know when a metal reacts with oxygen, a metal oxide is formed. Here are some examples. When magnesium is combined with oxygen to form magnesium oxide. When copper combined with oxygen to form copper oxide. When iron combines with oxygen, iron oxide is formed. So these are the metal oxides. Next is the reactions of metals with water. The group 1 metals react vigorously with water. The metals nearest the bottom of group 1 in the periodic table react more vigorously than those at the top. Some metals will react with hot water or steam, but not with the cold water. Here are some examples. Calcium, it sinks in cold water. Hydrogen gas is released and cloudy solution of calcium hydroxide is formed when calcium reacts with the water. When copper reacts with the water, it sinks in cold water. It does not react with the water or with the steam. When sodium reacts with the water, means it floats on water. It reacts with the cold water to form hydrogen with the fizzing sound. You know the fizzing sound? Hydrogen pushes the metal on surface of the water and metal bursts into flame. Clear solution of sodium hydroxide is formed. Some other example also. When magnesium reacts with the cold water and produces hydrogen slowly, a solution of magnesium hydroxide is formed. Reaction is vigorous. When potassium, it is float on water, it reacts with the cold water and it bursts into flame vigorously. Hydrogen bubbles produce rapidly around the metal. Clear solution of potassium hydroxide is formed. When iron reacts with the steam, hydrogen production is very slow and then the iron sinks in the water. Next is the reaction of metals with acids. When a metal reacts with a dilute acid, the products are a salt and hydrogen. The different metals have different levels of reactivity in dilute acid. When sodium reacts violently with dilute hydrochloric acid to give sodium chloride and hydrogen. Sodium chloride means salt. Potassium reacts violently with the dilute hydrochloric acid to give potassium chloride and hydrogen. Lead does not react with the dilute hydrochloric acid. It reacts with the concentrated hydrochloric acid to produce hydrogen gas slowly and lead chloride is formed. Here we can see how these metals are react with acids. When zinc reacts slowly with the dilute hydrochloric acid to produce zinc chloride and hydrogen gas. When copper, there is no reaction with the dilute or concentrated hydrochloric acid. Magnesium reacts quickly with the dilute hydrochloric acid to produce magnesium chloride and oxygen. Here we can see the equations. When magnesium plus hydrochloric acid gives magnesium chloride plus hydrogen. Then what about aluminium? Aluminium react with hydrochloric acid to form aluminium chloride and hydrogen. Zinc react with hydrochloric acid to form zinc chloride and hydrogen. Understood? So, when a metal reacts with an acid, the products are a salt and hydrogen gas. Look at the reaction. Metal plus acid gives salt plus hydrogen. The salt produced depends on the metal and type of acid involved in the reaction. When a metal reacts with hydrochloric acid, the salt produced is a metal chloride. When a metal reacts with sulfuric acid, the salt produced is a metal sulfate. When a metal reacts with nitric acid, the salt produced is a metal nitrate. Here are some equations. When calcium combine with hydrochloric acid to form calcium chloride plus hydrogen, but this calcium is combined with the nitric acid, calcium nitrate plus hydrogen. The same calcium is combined with sulfuric acid to form calcium sulfate and hydrogen. Then what about the zinc? Zinc react with hydrochloric acid to form zinc chloride plus hydrogen. What about the magnesium? Magnesium reacts with nitric acid to form magnesium nitrate and hydrogen. Magnesium reacts with sulfuric acid, magnesium sulfate and hydrogen are the products. Here we can see the reactivity series of metal in order of reactivity. The topmost means more reactive than the lowermost. Children, see this video.
Relative reactivity of metals. Some metals react more easily than others. A reactive metal is one that readily reacts with other elements to give up its electrons, whereas a less reactive metal is one that does not lose its electrons easily. The most reactive metals will react even with water, while the least reactive will not react even with concentrated acid. Displacement reactions, which are very common in metals, can be used to find out the relative reactivities of metals. In this reaction, a more reactive metal displaces a less reactive metal from its salt solution. In the order of reactivity from the highest to the lowest, metals are arranged in a reactivity series or activity series, which is used to summarize information about the reactions of metals with acid and water, single displacement reactions, and the extraction of metals from their ores. In this experiment, our aim is to observe the action of iron, copper, zinc, and magnesium on the solutions of copper sulfate, zinc sulfate, aluminium sulfate, and silver nitrate, and arrange them in the order of reactivity based on the results observed. Materials required: small pieces of iron, copper, zinc, magnesium, aqueous solution of copper sulfate, zinc sulfate, aluminium sulfate, and silver nitrate. Procedure: to test the reactivity of iron in the solution of copper sulfate, zinc sulfate and aluminium sulfate, take small pieces of iron and put them into the beakers containing copper sulfate, zinc sulfate and aluminium sulfate solutions. Leave the beakers undisturbed for 1 day. After a day, the color of copper sulfate solution turns from blue to light green and red-brown particles of copper settle at the bottom of the beaker. This indicates that iron is more reactive than copper, as Fe2 plus ions displace Cu2 plus ions from copper sulfate solution. In the other two cases, there is no change observed. This indicates that iron is less reactive than the other two metals, aluminium and zinc, so it cannot displace these metals from their salt solutions. To test the reactivity of copper in solutions of silver nitrate, aluminium sulfate and zinc sulfate, add pieces of copper into the silver nitrate, aluminium sulfate and zinc sulfate solutions. After a day, the colorless silver nitrate solution changes to blue-colored copper nitrate solution and silver particles settle down at the bottom of the beaker. Here, copper is more reactive than silver, so it displaces silver from silver nitrate solution. In the other two cases, since copper is less reactive than aluminium and zinc, there are no changes observed in their salt solutions. To test the reactivity of zinc in the solutions of copper sulfate, aluminium sulfate and silver nitrate, take small pieces of zinc and add them in the beakers containing these salt solutions. After a day, we can observe that red-brown particles of copper settle down at the bottom of the copper sulfate solution. This indicates that zinc is more reactive than copper and it displaces copper from the copper sulfate solution to form zinc sulfate. In the case of silver nitrate, since zinc is more reactive than silver, it displaces silver from silver nitrate solution and particles of silver settle down at the bottom of the beaker. But in the case of aluminium sulfate, no change is observed as zinc is less reactive than aluminium. So zinc cannot displace aluminium from aluminium sulfate solution. To test the reactivity of magnesium in the solutions of copper sulfate, silver nitrate and zinc sulfate, add small pieces of magnesium into the beakers containing these solutions and leave them undisturbed for 1 day. After a day, we can observe that copper, zinc and silver particles settle down at the bottom of the beaker containing the respective solutions. This indicates that magnesium is more reactive than copper, zinc and silver. So it displaces copper from copper sulfate solution, zinc from zinc sulfate solution and silver from silver nitrate solution. From these reactions, we can infer that iron displaces copper, zinc displaces copper and silver, and magnesium displaces zinc, copper and silver. So magnesium is the most reactive metal and copper is the least reactive metal.